We are Team 2, and we are going to be presenting the real-life applications of quadratic functions. We should remember that quadratic functions are parabolas, and those are seen the most in their vertical form, so we will be focusing on them. First of all, we should explain the main definitions needed for the rest of the presentation. So my teammate Kail will take the word.
To start, we will talk about quadratic functions, which is a function that can be described by any equation of the form fx equal to ax plus bx plus c, where a is not equal to 0. In a quadratic function, the greater power of the variable is 2. To graph a quadratic function, we use a parabola. Now let's talk about what a parabola is. A parabola is a curve where any point is an equal distance from which is the focus, a fixed point, and the fixed straight line, which is the directrix. Now let's talk about the parts of a parabola. First, we have the vertex, which is the point at where a parabola changes direction, corresponding to the minimum or maximum value of the quadratic function. Then we have the axis of symmetry, which is a vertical line drawn through the vertex of a parabola around which the parabola is symmetric. And let's finish with the zeros, which is a given function that values at c with y equals to 0, which is called roots. Now, I'm going to introduce you to the points of a parabola. The y-intercept is the point at which the parabola crosses the y-axis. There cannot be more than one such point for the graph of a quadratic function. Either way, the curve will not be a function, and there will be two values for 1, x valued as 0. And then we have the x-intercept, which are the points at where the parabola crosses the x-axis. If there exists, the x-intercepts represent the zeros or the roots of the quadratic function. The values of x at which y equals to 0, there may be 0, 1, or 2 x-intercepts. The number of x-intercepts varies depending upon the location of the graph.
The quadratic function expresses the relationship that solves a quadratic equation, which are presented as follows. Y equals ax squared plus bx plus c. To solve it, the equation must be balanced in such a way that the value of x gives as a result the value of y, and that this is equal to 0. So the equation must be formulated as ax squared plus bx plus c equals 0. For example, we start by making the result of the equation equal to 0. So we subtract 6 from both sides, and we obtain 4 times 2 plus 3x minus 11 equal to 0. And now we use the general formula, which is going to give you two values, the minimum value and the maximum value. Now we're going to talk about graphing. The graph of a quadratic function is a curve called parabola. Parabolas may open upward or downward and vary in width or steepness, but they all have the same basic U-shape. The way to graph is forming a table with the values that variables x and y can take and representing the values in the plane. The result is a curved line called parabola. For example, in this case, if we make a table with the values of this function, we see that the range do not behave a linear function. In a linear function, the value of y changes by the same amount each time the value of x increases. This does not happen with a quadratic function. After making some points, we draw a curve connecting the points, and now we have a parabola.
Real-life examples. Satellite dishes. The standard dish consists of a parabolic bowl-shaped surface and a central feed horn. To transmit a signal, a controller sends it through the horn, and the dish focuses the signal into a relatively narrow beam. Headlights. The optical property is also responsible for parabola-shaped unidirectional lights, such as car headlights. If a bulb is placed at the focus of a parabolic mirror, the light rays reflect off the mirror parallel to each other, making a focused beam of light. Parabolic microphones. The special shape of the parabolic dish collects the incoming pressure sound waves and focuses into a single point. The microphone then converts this into electrical signal.
I'll be the one explaining a real-life application of a quadratic function, the parabola. Let's read the problem. The parabolic cables of a 200 feet portion of the roadbed of a suspension bridge are positioned as shown. Vertical cables are to be spaced every 20 feet along this portion of the roadbed. Calculate the lengths of these vertical cables. So let's pretend the roadbed is the x-axis, and this will be our y-axis, and the point in blue, the vertex, at 0, 10. Being a vertical parabola, the equation will be x squared equals 4py, and using our vertex, it'll be this one. The length of the roadbed is 200 feet, so split in half it'll be 100. The vertical length of the major pole is 50 feet. Now using this data, we'll conclude that the point in blue will be 100, 50, and since 100 is in the x-axis, that'll be our x squared. By substituting the values, we will get p. So that'll be equal to 62.5. Once we get the p, now we could get the real equation to solve for the length cables. P times 4 is 250, and our x will be the length between the cables, which is 20 feet from each other. So 20 squared is 400, and using the distributive law to solve this, our first cable will then be 11.6 feet. Now we will search for the other cable's length by adding 20 feet each time, changing our x to 40, then to 60, and finally to 80, since the value of the fifth cable was already given by the diagram. Here we can see the process for the second one. It'll be 16.4 feet long, and then we'll go to the third one. As you can see, we changed the x to 60 now, and following the same process of the distributive law, it'll give us a length of 24.4 feet. And now we'll just skip right to the fourth one without using this process because we all know it. And so the fourth one will be 35.6 feet. So now we know how to use equations of the parabola to calculate things in the real world.
Our team focused on learning about quadratic functions and teaching the uses that we can give them in daily life. We learned that a parabola is the conic section of a centrally equal to 1. Resulting from cutting a right cone with a plane, we learned how to graph a parabola and the uses that we give it in our daily life.